Assalamualaikum dan selamat petang kepada semua pelajar. Kita masih lagi dalam suasana Hari Raya Aidilfitri. Jadi saya ambil kesempatan ini untuk mengucapkan selamat Hari Raya Aidilfitri kepada pelajar-pelajar yang beragama Islam. Baik, sebelum ini kita sudah belajar tentang standard representation for the atom. So this is the example of standard representation for potassium, ya. So 3919K. If you still remember, 39 is the nucleon number. This is the nucleon number. Nucleon number. 19 in this case is a proton number. K is the symbol of element, which symbol of element of potassium, which is K with capital letter. Yeah. Right. So from this standard representation, we know the nucleon number and also the proton number. If we want to find number of neutron, also can. If you remember, nucleon number is the total number of proton and neutron in the nucleus of an atom. You see? So if you want to find the neutron, you can use this equation. Nucleon number is equal to P plus N. Right. So from this example, we know that the proton number is 19, nucleon number is 39, number of protons is 19. So number of electron is 19. If you still remember, for atom which is neutral, the number of proton is the same as the number of electron. So that you see, proton carry positive charge and electron carry negative charge. So for atom which is neutral, if the number of proton is 19, so if you want to find the number of neutron, is 39 minus 19. So we'll get 20. So I'll give you an example. Element Q has a 8 neutron and nucleon number of 14. Represent the atom in the form of AZX. So you see AZX. So A should be the nucleon number. So nucleon number is 14. So right here is 14. And then below it is the proton number. So you should find the proton number first. So proton number is 6. So where do you get the 6? Use the formula nucleon number is equal to P plus N. You get 6. Right? P you get 6. So Q is the symbol of element Q. So this is the standard representation of atom for atom Q. So I'll give you another example. Nitrogen N has 7 neutrons and 7 electrons. Represent the atom in the standard representation of atom. So it is 14, 7, N. 14, 7, N. I hope you get it. Alright. So I proceed to the next one. Atomic structure and electron arrangement. So electron arrangement is the way in which the electrons are placed in the shell. Right? Electron arrangement is the way in which the electrons are placed in the shells. For the first 20 elements with the proton number of 1 to 20, that is from hydrogen to calcium in the periodic table of elements. So you see, this is the rules that we need to follow when we want to draw or we want to write the electron arrangement of atom. Yeah? Right. So for the first shell, can occupy only with 2 electron. Kalau nak lukis susunan elektron, you kena follow these rules. So first shell can occupy only with 2 electron. Second shell can occupy with 8 electron. Right? Third shell can occupy with 8 electron. Right? Actually, it can occupy up to 18 electrons. Yeah? I show you the example after this. The remaining electrons are filled in the fourth shell. Right, example. Calcium atom has 20 electrons. So the electron arrangement of calcium is, you see, 2, it has a 20 electrons. So how do we write the electron arrangement of calcium atom? So you see the first shell can occupy only 2 electrons. So 2. So you see it has a 20 electron. So the first shell can occupy 2. This one, 2 ya. So ada lagi 18 elektron kita belum lukis ya. So ingat balik rules. Second shell can occupy maximum 8 electron. So we put 8 here. And then we have 10 electron to be drawn, to be arranged in our electron arrangement. We have 10 more. So the third shell can occupy 8 electron. So minus 8. So we have 2 more electron. So where do we put this 2 electron? We put to the fourth shell, right? It's like this. So the electron arrangement of calcium atom is 2.8.8.2. So you see here 2 electron in the first shell, and then 8 electron in the second shell, 8 electron in third shell, and 2 remaining electrons in the fourth shell. I hope you get it there. Alright, I'll give you an example. Let's say we have the element of aluminium. Aluminium has proton number is 13. So you see, for the atom is neutral. So when neutral, the proton number is equal to the number of electron. So you see, when the proton number is 13, so number of electron is 13. So how do we write the electron arrangement for this 13 electron? So you see, the electron arrangement is 2.8.3. Ingat balik rules dia ya. So the first shell can fill up to 2 electron only. Boleh isi 2 elektron saja first shell ni. Kamu tengok balik sini ya. First shell boleh isi 2 elektron. Second shell boleh isi maximum 8 elektron. Third shell boleh isi maximum 8 elektron ya. Kalau ada lebih-lebih itu kita akan masuk dalam fourth shell. Right? So you see the electron arrangement is 2.8.3. For nitrogen, you see, alright, dia dah bagi kat sini, electron arrangement is 2.5. So, how do we find the proton number? Ingat balik, for atom neutral, so the number of proton is equal to the number of electron. When you know the number of electron, you know the number of proton. Then we know, you see, the electron arrangement is 2.5. Then we know the number of electron is 7. So the proton number is 7. For magnesium, the proton number is 12. Argon, 2.8.8. Right? Potassium is 2.8.8.1. Calcium is 2.8.8.2 ya. Kamu ikut saja rules yang ini. Ikut saja rules ni ya. I hope you get it. Okay. What is valence electron? Ni kamu terima dulu term-term ini. So valence electrons are the electrons in the valence shell. Valence shell is the outermost shell of an atom. Elements with the same number of valence electron will exhibit similar chemical properties. Right? So I give you example here. So you see, valence electrons are the electrons in the valence shell. So I give you example. Example is aluminium. Aluminium, the valence electron for the aluminium atom is 3. Is 3 ya. Okay, so valence electrons are electrons that occupy the outermost shell of an atom. Maksudnya shell, valence elektron ni adalah elektron yang berada di shell paling luar dalam sesuatu atom. Kalau kamu tengok sini, this is the outermost shell. So the valence electron for this case, valence electron for aluminium atom is 3. Right? Why is 3? Because the electron that occupy in the outermost shell of an atom is 3. So valence electron is 3. Elektron yang berada di shell yang paling luar adalah 3. Jadi valence electron adalah 3. Right? So valence shell is the outermost shell of an atom. Valence shell is the outermost shell of an atom. So valence shell. So valence shell ni adalah shell yang berada di paling luar. Shell yang berada paling luar dalam satu atom. Elements with the same number of valence electron will exhibit similar chemical properties. Example, let's say I have an electron arrangement of sodium atom which is 2.8.1 and then electron arrangement of potassium atom which is 2.8.8.1. You see both of the atom has the same valence electron which is 1 here. This is 1 valence electron. And then this is 1 valence electron. 1, 1. So all of sodium atom and potassium, both of them will have the same chemical properties. Why is that? Because both atoms have the same valence electron, which is 1. Right? So I give you an example. In this case, what is chemical properties? Chemical properties ini adalah sifat kimia, ya. Let's say I give you an example. Sodium atom Na will react with water to produce sodium hydroxide and hydrogen gas. Right? Okay, if I balance this equation, kamu akan belajar nanti balancing equation. So I will write like this. I will put here 2 here, and then I will put 2 here. Okay, so Na plus H2O will produce NaOH plus H2. This is a sodium hydroxide. NaOH ni adalah sodium hydroxide. So for potassium, which is K, dia akan react dengan H2O juga. So sama juga. Dia akan jadi nanti KOH plus H2. Jadi kamu nampak tak? Dia hanya ubah ini saja. Hanya ubah elemen saja. Yang produk yang lain semua sama. Okay? Baik. For this, in this case, 2K plus 2H2O will produce 2KOH plus H2. KOH ni adalah potassium hydroxide. Yang atas ni adalah sodium hydroxide. Yang bawah ni adalah potassium hydroxide. Okay? Baik, nampak tak? Dia trend dia sama saja. Dia akan jadi, kalau saya ada atom yang lain, dia sama juga. Dia akan jadi atom tersebut, kita tambah OH belakang dia, tambah H2. Dia semua trend dia sama saja. Ini menunjukkan bahawa both atom will have the same chemical properties. Right. Duplet electron arrangement is obtained when 2 electrons are placed in first shell only. Right? Duplet electron arrangement diperoleh apabila 2 elektron ditempatkan di dalam petala pertama saja, ya. Right. Octet electron arrangement is obtained when 8 electrons are placed in the outermost shell. Okay. For the elements in the periodic table, only helium atom has the duplet electron arrangement. Only helium atom in the periodic table of element, only helium atom has duplet electron arrangement. Duplet electron arrangement ni maksudnya dia ada dua elektron, atom itu ada dua elektron. Kemudian dua elektron ini berada dalam shell yang pertama saja. Okay, itu kita namakan dia duplet electron arrangement. Jadi elements di dalam periodic table yang ada duplet electron arrangement adalah helium atom saja. Alright? Okay. I'll give you another example here. Example, phosphorus atom has 5 valence electron and 3 shell filled with electron. Write the electron arrangement of phosphorus atom. So, dia kata phosphorus atom ni ada 5 valence electron and 3 shell filled with electron. So, macam mana kita nak tuliskan dia punya electron arrangement? So, kita start dengan 5 valence electron. Kita tuliskan 5 valence electron ini. Kemudian, you see dia kata dia ada 3 shell filled with electron. So, dia ada 3 shell yang berisi dengan elektron ya. So, tadi kita sudah tulis 5. This is the valence electron. And then the second shell should be 8. And the first shell should be 2 ya. So 2.8.5. Baik. Potassium atom has 4 shell filled with electron and 1 valence electron. What is the electron arrangement of potassium atom? So dia sudah bagi valence electron which is 1. So kita tulis dulu valence electron dia. And then dia kata 4 shell filled with proton. Maksudnya dalam atom ini dia mempunyai 4 shell. So this is the 4th shell which is 1. And then third shell should be 8. And then second shell should be 8. And the first shell should be 2. So 2.8.8.1. Right. So number of neutron in sulfur 34 atom is 18. Calculate the number of electron in sulfur 34 atom. So, kalau atom kamu, dia tulis macam ini, sulfur 34, bermakna 34 kat sini adalah nucleon number. Dia boleh jadi macam-macam ya. Dalam kes ni tulis sulfur 34. 34 itu bermaksud nucleon number ya. Jadi kamu jangan pelik pula, what is this? This is the nucleon number. The number is nucleon number ya. So, dia kata number of neutrons in sulfur 34 atom is 18. So, calculate the number of valence electron in sulfur 34 atom. So, kamu sudah tahu nucleon number, kamu sudah tahu number of neutron. So, boleh tak calculate proton number? Boleh. Gunakan formula nucleon number is equal to P plus N. So, selesaikan itu, you get the proton number which is 16 ya. So, number of electron is 16 because this is the atom. So, it is neutral. When neutral, the proton number is equal to the number of electron. So, electron arrangement is 2.8.6. So, number of valence electron is 6. So, draw the electron arrangement of lithium atom given that lithium atom has 3 proton. So, tadi kita sudah belajar macam mana nak tulis electron arrangement. Sekarang ni kita nak belajar macam mana kita nak lukis, draw the electron arrangement. So, macam mana kita nak draw? First, you should start with the symbol of element. So, lithium atom, the symbol of lithium atom is Li. Baik. Lukiskan dia punya nucleus of Li. nucleus of Li ni saya tak berapa round sangat lah. Kalau boleh betul-betul round Li. Kemudian dia kata dia ada 3 protons. Maksudnya bila 3 protons ni atom, bila atom dia neutral. Bila dia ada 3 proton bermakna dia ada 3 elektron. So kita nak lukiskan 3 elektron ini ya. So mula-mula kita start dengan symbol of element which is Li. Kemudian dia punya nucleus. And then buat dia punya first shell. First shell boleh isi maksimum berapa? 2 saja. So 2. Kamu boleh buat bulat macam ni ataupun kamu boleh buat cross macam ni. Cross macam ni pun boleh juga sebagai elektron ya. Alright. And then the second shell is 1 electron. 1 electron here. So let's say saya nak buat bentuk cross ya. Saya tak nak buat elektron itu dalam bentuk bulat. Okay, so saya akan buat start ni macam ni, sama juga Li. Kemudian dia punya nucleus. And then first shell. First shell boleh isi maksimum 2 saja. And then second shell. Second shell boleh isi maksimum 1. Boleh isi maksimum 8. Okay, tapi kita belum lukis satu lagi. So satu lagi itu kita akan masukkan dalam second shell. Okay, this is the electron arrangement of lithium atom. Alright, draw the electron arrangement of chlorine atom with 17 electrons. So sama juga, lukiskan symbol of element of chlorine which is C with capital letters and L huruf kecil ya. Cl. Kalau chlorine, dia punya symbol of element is Cl. Right? Kemudian buat nucleus dia and then buat first shell ada 2 elektron, second shell ada 8 elektron, and then third shell ada 7 elektron ya. Okay. Table 2.8 shows the difference between electron arrangement diagram and the atomic structure diagram. Jadi sebenarnya kalau kita buat electron arrangement diagram, dia bentuk dia macam yang saya tunjuk tadi lah. Symbol of element, kemudian nucleus, and then first shell, second shell, and so on lah. Kalau kamu disuruh untuk membuat atomic structure diagram, okay, cara dia sedikit berbeza. You see? So, sama juga, mula dia ada nucleus that is labeled with symbol element, ni sama. Number of proton and neutron in the nucleus. Dia mesti kamu tulis dia punya nucleus, kemudian tulis berapa banyak proton dia, berapa banyak neutron. Macam ni. Kamu kena labelkan label nucleus, kemudian tulis berapa banyak proton, berapa banyak elektron dia. Kemudian labelkan shell dia. Labelkan elektron. Itu macam mana kita nak buat atomic structure diagram. Sama saja, cumanya kamu kena labelkan. Ini elektron, yang mana nukleus, kemudian dekat nukleus tu kena tulis berapa banyak proton, berapa banyak neutron ya. Tulis di mana shell. Baik. I want to proceed to the next subtopic, which is isotope and its uses. What is isotope? Isotopes are atoms of the same element with the same number of protons but different number of neutrons. Isotop ni apa? Dia adalah atom bagi unsur yang sama dengan bilangan proton yang sama tetapi bilangan neutron berbeza. Atoms of the same element with the same number of protons but different number of neutrons. Isotopes can also be defined as the atom of the same element with the same proton number but different nucleon number. Jika membayangkan isotop ni adalah atom bagi unsur yang sama dengan bilangan proton yang sama tapi bilangan neutron yang berbeza. Jadi bila bilangan neutron berbeza, sudah tentu bilangan number neutron dia berbeza. Jadi itu sebabnya dia ada dua definisi di sini ya. Right? Kamu tengok ni, bila ini berbeza, neutron berbeza, sudah tentu nucleon number pun berbeza. Tetapi atom itu dia mempunyai same proton number. Isotopes of the same element have similar chemical properties because they have same number of electrons. Right? Isotopes of the same element have similar chemical properties. Why? Because they have the same number of electrons. Isotopes of the same element have slightly different physical properties because of different number of neutrons. Baik kalau yang ini kalau saya bertambah poin nombor 3 ni kelas, isotopes of the same element have similar chemical properties because they have the same valence electron, have the same valence electron ya. Itu lebih, itu pun diterima juga ya. Kenapa isotope of the same element ni mempunyai similar chemical properties? Why? Because they have the same valence electron. Valence electron ni sama. That's why they have a similar chemical properties. Right? Isotopes of the same element have slightly different physical properties because of different number of neutrons. Isotop ini walaupun dia mempunyai similar chemical properties, tetapi mereka ini mempunyai sedikit perbezaan sifat fizik, slightly different physical properties. Why? Because they have the different number of neutrons. I give you example, hydrogen 1. Ingat lagi, kalau saya tulis macam ni, hydrogen 1, maksudnya 1 kat sini merujuk kepada nucleon number. So, hydrogen ini mempunyai nucleon number 1. Right? So, hydrogen 1 ataupun nama lain bagi hydrogen 1 adalah protium. For hydrogen 1, it has a 1 proton number and 0 neutron. Dan hydrogen juga dia wujud dalam bentuk 21H. 21H maksudnya, ataupun saya boleh panggil dia deuterium. Okay, for 21H, it has a 1 proton and 1 neutron. Hydrogen juga dia wujud dalam bentuk 31H. Ataupun nama lainnya adalah tritium. In 31H, it has a 1 proton and 2 neutron. Jadi kamu nampak tak hydrogen ini? Semua atom dia sama. Okay, tetapi atom yang sama, yang mempunyai proton number yang sama, nampak tak proton number ni semua sama satu. Tetapi mempunyai number of neutron yang berbeza. Nampak tak? Number of neutron dia berbeza. Jadi ini adalah isotopes. Okay, example. Carbon juga dia wujud dalam bentuk carbon 12, carbon 13, carbon 14 ya. Nampak tak? Semua ini carbon ni, carbon 12, carbon 13, carbon 14 ni semuanya proton number ni sama, which is 6. Tetapi berbeza apa? Number of neutron. Ini carbon 12, it has a 6 neutron. Carbon 13, it has a 7 neutron. And then carbon 14, it has a 8 neutron. Okay? Baik. Tengok kalau dia punya number of neutron dia berbeza, so proton dia punya nucleon number dia pun berbeza. Jadi kalau proton number dia, kalau isotop ni dia punya proton number dia sama tetapi berbeza neutron number ataupun berbeza nucleon number. Sebab kalau number of neutron berbeza, sudah tentu nucleon number pun berbeza ya. Oxygen 16, it has 8 proton, 8 neutron. Oxygen 17, it has 8 proton and 9 neutron. Oxygen 18, it has 8 proton and 10 neutron. Chlorine 35 has 17 proton and 18 neutron. Chlorine 37, it has 17 proton and 20 neutron. Apa isotopes ni? Baik. Bromine 79, it has 35 proton and 44 neutron. Bromine 81, it has 35 proton and 46 neutron. Sulfur 32, it has proton number 16. And this one, proton number 16. Number 16 ya. Kamu boleh kira sendirilah. What is the number of neutron dia. Mungkin dia tak muat kot itu sebab dia tak tulis kat sini ya. For sure nanti dia punya number of neutron dia berbeza. Ya. Alright. Example. Uranium-235 and uranium-238 are two uranium isotopes. The number of neutrons in uranium-235 is 143. How many neutrons are there in uranium-238? So you see number of protons in uranium-235 is 235 minus 143 equal to 92. So how do we get this? So you see, ingat balik. Okay, we get from the formula ya. Nucleon number is equal to P plus N. So when you want to find the proton number P only, so P is equal to nucleon number minus N. So you get this. Right? So calculate, you get 92. This is the number of proton. Right. So what is the neutrons are there in uranium-238? Kita nak tahu sekarang ni number of neutrons in uranium-238. Okay. Tapi dia bagi number of neutron in uranium-235. Okay, jadi tadi kita dah selesaikan soalan ni. So, kita cari dulu number of protons in uranium of 235. Oleh sebab ini adalah isotop, jadi bila kita tahu protons in uranium-235, we know the number of protons in uranium-238. Because ini isotop, bila isotop, proton number dia sama. Bila ini 92, ini pun 92. If you know the number of proton, which is 92, then you can find the number of neutron in uranium-238. Sebab kita tahu 238 ni adalah nucleon number. So kita tahu proton number. So kita boleh dapat the number of neutron ya. Alright. Ini saya sudah terangkan tadi lah. Uranium-235. So the number behind the element name is the nucleon number of that element. Baik. Example ya. Atom L and 14,6M are two isotopes. Given that the nucleon number of atom L is 13, calculate the number of neutrons in atom L. Okay, dia kata L dengan M ni adalah two isotop. Bila isotop kita tahu L dengan M ini mesti mempunyai proton number yang sama. Alright. So dia dah bagi kat sini L ini nucleon numbernya adalah 13. Calculate the number of neutrons in atom L. So macam mana nak selesaikan ni? So kamu sudah tahu so cari number of neutron in atom L. Baik, kamu kena cari dulu proton number of M. Dah cari proton number of M, kamu tahu dia punya proton number of L. Tahu proton number of L, tahu nucleon number of L, kamu boleh terus cari dia punya number of neutron. Okay, sekejap. Baik so saya harap kamu dapat ini. Okay, kita terus untuk yang seterusnya, B, relative atomic mass of isotope. Okay, saya harap kamu dapat fokus ya. Ini sebab saya buat video ini pun ramai orang datang rumah. So Terpaksa nak tak nak kita terpaksa jugalah. Saya terpaksa juga terangkan sebab ini semua akan masuk dalam ujian ya. Baik. B. Relative atomic mass of isotope. Most elements exist naturally in a few isotopes. The mass of the element depends on the natural abundance of isotopes. Natural abundance of isotope is the percentage of isotopes in a sample of an element. The relative atomic mass can be calculated from the natural abundance of element that has isotope using the following formula. Relative atomic mass is equal to this one here. Ni the sum of percent isotope times mass of isotope divided by 100. Baik, tak apa. Kalau kamu tak faham ni, kamu tengok ya. Okay, tengok contoh ni. Chlorine exists as two isotopes, 3570 Cl and 3770 Cl. If the natural abundance of 3570 Cl is 75%, what is the relative atomic mass of chlorine? Baik, so kita tulis dulu formula. Relative atomic mass is equal to the sum of percent isotope times mass of isotope divided by 100. Okay, so since chlorine 35 occupies 75%, definitely chlorine 77 occupies 25%. So kamu tengok di sini, kalau kita nak cari relative atomic mass of this Cl ya. So 75% of isotope ini, first isotope ni 75%. Okay, natural abundance of 3570 Cl is 75%. Okay. For natural abundance of 3570 Cl is 75%. So 75% times the mass of isotope, which is 35. So you see mass of isotope is 35. Ingat balik ya, most of the mass of atom is located in the nucleus. Because kamu ingat balik, jisim proton dengan nukleus, the mass of neutron and proton is so high compared to the mass of electron. Jadi kalau dia punya nuclear number is 35, so the mass of the isotope is 35. Okay, plus percent of isotope of 35%, sebab ini 75%, ini 75%. So bakinya adalah 25% bagi ni ya. 35% times the mass of isotope, which is 37, divide by 100 ya. So you get 35.5. Baik, I give you another example. Natural abundance of copper 63 is 69.17%, whereas natural abundance of copper 65 is 30.83%. Determine the relative atomic mass of copper. So 69.17% times 63 plus 30.83% times 65 divide by 100 ya. You get 63.6166. Try to use calculator. You get or not this value. I gave you another example. Given the relative atomic mass of thorium, which consists of isotope thallium-203 and thallium-205, is 204.4. What is the percentage of thorium-203 atom in the isotope mixture? Okay, kita tahu sekarang ni relative atomic mass of this thallium is 200.4. So sekarang kita nak tengok what is the percentage of thorium-203 atom in the isotopic mixture ni, berapa persen dia. So X%, ni kita tak tahu X% times 203, plus percentage of thorium 205 is 100 minus X. Okay, 100 minus X, kita tahu ini. Time 205 divide by 100. So, kamu cari X ini, kamu akan dapat the percentage of thallium 203, which is 30%. Okay, kalau saya tambah soalan sikit, let's say saya nak tahu percentage of thorium 205 berapa. So, 100% tolak dengan 30%, 70% lah. So, thorium 205 is 70%. Right. Uses of isotope. Isotope can be divided into radioactive and non-radioactive isotope. Radioactive isotope are also known as radioisotope. Radioisotope may produce harmful radiation, but some radioisotopes are useful in our daily lives. Jadi, isotop ni ada kegunaan dia, ya. So, kamu tengok di sini, untuk bidang medicine, the isotope cobalt-60, they uses radiotherapy for the treatment of cancer, iodine-131, to treat thyroid cancer and to diagnose thyroid gland tumors. So, 24, to determine the location of blood clot in blood vessel. In the field of agriculture, phosphorus 32, to study the rate of absorption of phosphorus in plants. Carbon 14, to study the path of carbon during photosynthesis. Right. In archaeology, for as carbon 14, to estimate the age of fossil and artifacts, which is carbon dating, pentarihan karbon. Kita boleh gunakan carbon 14 untuk tahu usia fosil dan artifacts. Lead to 120, lead to 110, lead to 210 to determine the age of sand and earth layer up to 80 years. Right. In industry, we have a sodium-24 to detect the leakage of underground pipe. Hydrogen-3 as a detector to study the sewage and liquid waste. Food preservation, we have a cobalt-60 to kill bacteria in food without changing the quality of food. In the field of nuclear energy, we have a uranium-235, fuel in the nuclear reactor to generate electricity. This kind of isotope, the users of isotope, kena hafal, ya. Kadang-kadang dia masuk dalam objektif ataupun dalam structure. Mungkin itulah, memang selalu keluar lah benda-benda ni, ya. So, I hope setakat ini dulu kita punya discussion. Saya harap kamu semua dapat faham, tapi banyak kekangan lah bila gunakan video macam ni, sebab tak ada feedback daripada kamu, saya tak dapat tanya kamu. Tapi apapun, saya ucapkan selamat berjaya menjawab ujian 1. So, kalau ada apa-apa soalan, kamu terus tanya saya dalam grup, dalam Telegram. Boleh PM saya ataupun tanya dalam grup kimia. So, I hope you doing well and success in your test 1. Thank you.